All right, so how do we put all of these pieces together to ID our unknown samples? Let's start with Mike's sample. Here's the photo he took from the sample they used to create his DNA barcode. And let's look at the evidence we have from our DNA barcoding analyses. Number one, we have our best blast hits. According to the percent sequence similarity matrix, Pluteus cervinus and P. petacetus were our two best blast hits. The alignment lengths were 593 base pairs, which beat our 400 base pair cutoff to be labeled as quote-unquote trustworthy. And when we looked at our number of mismatches divided by our alignment length for those blast hits, they were about 13 mismatches for those 593 aligned base pairs, which is about 2% mismatch, which is greater than our 1% cutoff to ID to the species level. When we look at our overall percent sequence similarity, Pluteus cervinus and P. petacetus both had a 97.96% similarity, which is, of course, very good, but also less than our 99% rule of thumb needed to ID to the species level, or typically used to ID to the species level. When we look at the results of our NJ and ML trees, both P. cervinus and petacetus were the closest relatives to Mike's samples. They were equally related in both the NJ tree and ML tree analysis. Furthermore, if you go and Google search images of those two species, cervinus and petacetus, this is what the images look like. And they look very similar to Mike's samples. So it's difficult morphologically speaking, without having a sort of more expert level of knowledge. It's difficult to tell which of those two it might be. So that doesn't help us discriminate further. Likewise, if we look at the known geographic ranges of P. cervinus and petacetus, they're both all over the eastern North America, so they're within the range of where we would have found them. So that doesn't help us eliminate which one of these species it might be either. So in summary, our blast, percent similarity, neighbor joining, and ML trees all give sort of similar info in the sense that it's going to be one of those two species, but we can't be sure which. So we can only be sure that Mike's sample is in the Pluteus genus. Photos and geographic ranges also support this idea that it's in the Pluteus genus, and it's likely one of these two species, either cervinus or petacetus, but we can't say which for sure from the data that we have up to this point. Next, let's look at Jessica's sample and the evidence we have from our DNA subway analyses. Her best blast hits were Pluteus ongoi. The alignment length was 588 base pairs, which beats our 400 base pair cutoff to be trustworthy. There were 0 mismatches in this alignment, so there's a 0% difference between that and the blast hits, so it's definitely below our cutoff to ID to the species level. Percent sequence similarity was 100% similar to two different Pluteus ongoi samples, so once again, this beats our 1% cutoff to ID to the species level. Our NJ tree and ML tree both support Pluteus ongoi as the closest relative and IDing it to the species level. When you do a Google or INAT search for images of that species, you can see that morphologically speaking, it's very similar to the photo that Jessica took. So that also supports it being this species. And if you look at the range map of Pluteus ongoi, they're found all over eastern North America, even here in the Harrisonburg area. So all of these pieces of information, using the totality of information together, that all supports her sample being Pluteus ongoi. Our blast, percent sequence similarity, neighbor joining tree, ML tree, all support IDing the sample to Pluteus ongoi. Sequence length, sequence quality, the number of mismatches, the percent similarity, all exceed the rough thresholds to ID to the species level, and our photo and range maps match. So the conclusion we can probably safely draw from this is that Jessica's sample is likely the species Pluteus ongoi. So the challenge I pose to you is to collect all of that information to ID Luisa's sample. And I am not going to provide you the answers. It's up to you to figure that stuff out and draw your own conclusions. And then do the same for Trey's sample. And once again, I'm not going to provide the answers in this case. It's up to you to figure it out and do your best. Good luck.